Alrighty, hi again, Algebra 2. This is where we left off the example 2 word problem in our last video. So let's keep going with linear equations. Let's talk about standard form. So standard form, this is our definition here. It's ax plus by equals c, where a, b, and c are integers. With a, oh, hello kitty cat Shadow. This is my cat Thor. You can see his shadow. He'll make it onto camera someday. Sorry about that. Here we go. A, b, and c are integers with a greatest common factor of 1. A is greater than or equal to 0, and a and b are not both 0. And then I have some examples down here. So let's just dissect what this definition means for a second. So a, b, c, they're your constant numbers. A and b are your coefficients in front of x and y. Where a, b, and c are integers. That should tell you we can have negatives. That's fine. So negatives and positives are okay. But fractions and decimals are not. So I cannot have fractions. I cannot have decimals. So we need to know how to get rid of fractions and get rid of decimals, and that's going to happen by multiplying some things. So we'll get to some examples with that in a moment. Okay, they have a greatest common factor of 1. We're going to see an example in a moment where they don't have a greatest common factor of 1, and it's your job to divide away the greatest common factor. So like if all of your a, b, and c values are divisible by 5, you need to divide the 5 away. That's all that's saying. A is greater than or equal to 0. A is the only one that has to be positive. B and C are allowed to be negative. That's fine. And then lastly, A and B are not both 0. Take a look at this example for a second. B is 0. I have 4x. The A is 4. A is greater than or equal to 0. A is an integer. B is 0. Which fits the integer category, but I'm not allowed to have both of them be 0. So if b is 0 and that's it, that's fine. So that's an example of standard form right there. This is another one, more of a filled out standard form. I have a, b, and c. That's 3, 5, and 12. A is just 3. It's not 3x. A is just 3. And notice 3, 5, 12, they have no factors in common. I can't divide out something from a 3, a 5, and a 12. So that is, in its simplest form, that is my standard form of that linear equation. So let's look at some examples. This one, pretty easy to start. I see my y and my x are on the wrong sides of the equation. I need to fix that. So what I'm going to do is subtract this 4x off to the other side, because I'm trying to write this in standard form, which has my x and y on the same side. So I have negative 4x plus 2y equals 5. Now, I'm not allowed to have a be negative, so I'm just going to multiply everything by negative 1. When I multiply everything by negative 1, don't forget to distribute that into the a and the b. So I'm going to get positive 4x minus 2y equals negative 5. Hopefully you just caught that I had dropped my negative, but I caught it, fixed it there. Hooray. So a is positive 4, b is negative 2, c is negative 5. Now 4 and 2 have a factor of 2 in common, but 5 doesn't. Therefore, I am done. Their greatest common factor of all three of them is 1. So I am done at this point. Hooray. So take a look at this one. I want you to try this one on your own. Write this in standard form. Get ax plus by all by itself equaling c. And remember, if there is a greatest common factor, you need to divide it away. So try that one. So let's see how we do this one. I see that x and y are already on the same side, which is good, but I want to add this 9 off to the other side. So I have 3x minus 6y equals 9. Okay, so far so good. I have all integers. I see that my a value is positive 3. I see that I don't have both of these being 0. That's good. However, I see that 3, 6, and 9 all have a common factor of 3. So I'm going to divide out that 3 and cancel it away. Because remember, I can do anything I want to both sides of the equation. So if I divide this by 3 on both sides, I like to use another color for this one. When I divide this subtraction problem by 3, both pieces have to get divided by 3. So 3x divided by 3 leaves me with a single x, minus 6 divided by 3, I'm left with a 2y. 9 divided by 3, I'm left with 3. So my a value technically is 1. My b value is -2. My c value is 3. There we go. Cool. Last example with this, I want to write this linear equation. Example 5 here. Write this linear function, linear equation, in standard form. Now I have a fraction to deal with in this case. So what I'm going to do is deal with that fraction right away. I see the denominator is 10, so I am going to get rid of that denominator by multiplying everything by 10. When I do that, notice here there is a negative. Multiplying by 10 does not get rid of that negative, so I am still left with -3x equals, distribute that 10, I have 80y minus 150. I need my x and my y on the same side, so I'm going to subtract that 80y. X's and y's are not like terms, remember that. So I have -3x minus 80y equals -150. So checking my definition, I have a, b, and c are integers. That's good. They don't have any common factors other than 1. But a is not greater than 0, so I'm just going to multiply everything by -1. I'm left with 3x plus 80y equals positive 150. Looks good to me. There we go. Cool. Let's say real quick, kind of a mini example, let's say you have decimals instead of fractions like that. Let's say maybe I have something like 0.25x plus 7y equals 22, for example. Just making that up off the top of my head. I see 2 decimal places. There's 2 ways to think about this. If you want to turn this back into a fraction of 1/4, you can multiply by 4. So 2 different ways if you're a fraction fan. If you multiply everything by 4, life will be good. So multiply everything by 4 to clear out the denominator. Or other option, so this is clear the denominator. The other option is if you want to clear away the decimal. And by doing that, what I want to do for there is, since I see that this is 2 decimal places, if I move this decimal 2 spots over, it would just be 25, and that would be nice. So if I multiply by 100, that's going to move that decimal place 2 spaces. It's also going to move the decimal place of both of these guys as well. So we might need to do some simplifying, some canceling with GCF before we move on. So if I multiply everything by 100, I have 25x plus 700y equals 2200. So I might need to divide by 5, at least to start. I don't know if they have anything farther than that in common, but I could divide by 5 on both sides and see what I get from there. So I'm not going to finish that example. That's just a quick thing to show you how to deal with the decimals. Okay, so I'm going to cut the video again here because I don't want to make the video too long. So stay tuned for part 3, where we'll do the final thing we need to do in section 2.